right. Well, thanks everyone. So we're going to be talking about in-memory computing here, getting hopefully some insights into what's going on and what's going to be happening in the future. So first of all, if I could just ask everyone to go down the line and introduce yourself, and if your company is using in-memory computing, maybe just give a brief idea of how you're using it today. Sam?
Sam Lawrence, FSB Technology. Yes, we're using GridGain. We've been using it for the last 3-4 years, and we're using it for, I guess, solving a few of the kind of complex problems, sports data, risk calculation, and some distributed locks as well. I think going forward, I can see other problems where in-memory computing is going to provide a good solution. So, yep.
Thanks, Sam. Hi, I'm Chris Goodall, CG Consultancy. We run a consultancy business that works across a variety of different sectors, using different technologies, but we're seeing a real growth with in-memory computing, with about 3 main customers now in the travel space. So we've developed large-scale hotel search systems for customers and other use cases around that.
Good morning, everyone. My name's Tim Wood. I'm coming from ING Bank. Personally, I work on the financial markets side of the organization, where we've been using in-memory technologies to, I wouldn't so much say accelerate, but really enable meaningful portfolio analysis for the sort of emerging regulatory framework that we've had in the last 10 years. Apart from that, also on the retail side of the bank, my colleague David, who also gave a short talk yesterday morning, is using in-memory technologies for what you might sort of call mainframe offloading, so the ability to handle ever-increasing numbers of transactions from mobile devices and others, which the traditional back-end systems of retail banking are unable to cope with.
Right, so Matt Aslett, Research Director for Data Platforms and Analytics at 451 Research. I just spoke, so if you weren't aware of that, perhaps you really do have a memory problem, but not something that technology can help with.
Hi, I'm Bill Bain from ScaleOut Software, and I want to preempt that by first thanking Terry and GridGain for what they're doing for the in-memory computing community with these summits, bringing all of us together to discuss these important topics. We build in-memory data grids at ScaleOut Software, and we see them deployed in a variety of applications. For example, financial services applications, airline reservations, e-commerce, and other online systems. I think Matt's comment about customer engagement, when he was talking about, that's what brings all of this together. It's customer engagement, and that's probably going to be the big driver of the adoption of in-memory computing.
Okay. So next question, maybe Bill, you can go first here. What do you see as the most valuable future use cases of in-memory computing, and what about in-memory computing makes it more effective than other approaches?
I think the use, as Matt has, I just want to build on that idea of customer engagement. The term we've been using is operational intelligence. We heard that from an analyst about 4 years ago at a conference and said, that's a good way to describe this. So anytime you can move the data that's changing quickly, instead of having to move it to an offline system in the data warehouse for offline analysis, batch analysis, and then get results later and not be able to engage with the customer because of that, if you can move, if you keep the data in an online system like an in-memory data grid and do the analysis in place, you get performance benefits and you get immediacy, and you end up with more opportunities for competitive differentiation than you otherwise would have. And so you see that in virtually every application where you're handling fast-changing data. And not to talk too long, but just for example, airline reservations. We have a customer that is using it as a cache of reservations information, but when you rethink about that usage model, you see that there's an opportunity there to have a holistic view of the passengers and be able to analyze their travel in the moment and make spot changes and be able to assist them in ways that you can't when you just view this data statically as hosting it in a cache. So in-memory computing we see having value in just a wide variety of applications.
Yes, so just continue on that. I think, obviously I gave a retail example there, but I think as we saw, that customer engagement is really the primary driver, and that obviously applies across multiple industries. And so I'd say that's almost like the horizontal driver, and then we see that in financial services and travel, as you say, even in public services as well, less the customer, but from a citizen engagement perspective. So anything that it drives greater engagement from the organization to the ultimate end users is a key application.
Yeah, I think speaking for my own area, I think what we see is more and more data, but also that markets move faster and faster. So, traditional end-of-day analytics is no longer a particularly useful tool except for accountants. So, we have to account and say this is what we're reserving, but if tomorrow, the markets flip, then those values are already useless. So it's a combination of a growing amount of data that we need to analyze, more complex models, and you really then need a sort of a very scalable and very high-performance platform in order to perform these types of analyses. I think perhaps also just adding on to that, because I feel I'm talking about a bit of an old topic, we also see emerging machine learning technology, to think about how to price automatically. And this is also about, beat the human trader, but also take the human out of the link for more bread and butter operations like, when you're in a market as a market maker and you just need to make sure that you're pricing correctly. And there you don't really need a human to make a judgment for you.
Yeah, a large proportion of our business is derived through technical due diligence services that we offer to private investors, so private equity businesses, and they're typically investing in sort of established mid-cap type businesses that may have been around for sort of 10, 15 years, have fairly well-established technologies that are maybe a bit legacy, in inverted commas. And we've seen the use of sort of in-memory grids and in-memory technologies as a way of decoupling some of that sort of legacy or technical debt. And on a couple of the deals that we've assisted with, where we've provided people to go in and help with migration projects following M&A, we've used this technology or these technologies to almost ring fence some of the older systems that are heavily database dependent and unwind that into an in-memory platform in an iterative fashion that's maybe not so scary for the owners of the business and the investors. And I think the investors are purely looking at how to reduce cost as well, and we've seen it's reduced the dependency on hardware and all that, the other associated costs.
An industry example, again, for me, I mean, in sports betting, I think the part that people dive into, and is probably the kind of the sexiest bit, is calculating the odds, and it's the bit that if you can get those better, then you can make money. If you can predict what's going to happen in a football game more accurately, then there's a quick way to get rich. But you know what, even with more data, with more processing, sports betting is just inherently volatile. It's going to be. So, I think good luck to the people who are trying that. Some of them will do well and some of them won't manage it. I think probably going back to customer engagement, that's a bit where a big difference can be made. I do think, it's in terms of doing all this analysis, one of the problems that I see is actually what you then do with that data at the end of it. I mean, the web technologies are, still a bit of a mess. We've got this kind of combination of pull and push, and, how do you actually, you've got some great information on customers, what do you do with it? How do you reach outward to them? So I think that some of those problems need solving as well.
Okay, great. Next question, what do you see as the most important enablers for more effective in-memory computing usage in the future?
I think going back to the presentation this morning about persistence, which was fascinating, a lot of it far too detailed for my knowledge about memory, but I guess with sports betting, we've got quite a nice domain in that there's the data that you need in memory is the stuff which is live, and there's only a sort of small finite amount of events happening in any one day or week. And as events finish, you can take them out of memory and you can put them back to disk. So it's a nice kind of problem. If the machines go down, then, well, there's only a limited amount of data that you've got to load back quickly. So for us, it's, it's minutes. It's not as quick as I'd like, but it's, getting that data back into memory is still quite possible. I can see for other industries, for other problems, that's you can't do that. If you've just got a lot of data that you need to get back quickly, then you're stuck there. And you've got to have this resilience in these systems. You've still got to be able to deal with, failures, and that means that you've got to have reliable persistence there. So I think that part must make a difference going forward.
Yeah, I'd completely agree. I think that sort of the previous presentation about the persistent memory, that's a key thing. We've seen that the limiting factor with all of the use cases that we've looked at have been around partitioning of data, because you're limited with heap sizes or off heap, on heap, and the performance impact that might have. I think to have almost an infinite store of memory obviously opens up a whole new world of opportunity for the processing, and it would reduce the complexity of the deployments and the approaches that maybe the developers are taking as well to sort of code around these issues at the moment.
Yeah, Terry, just to confirm the question, you say what would be the enabler to more effective use of in-memory computing technologies?
Yeah, the most important
Yeah.
enablers.
Well, I think I would actually take a slightly different tack on answering this question. I sort of think about in terms of development. So if I can zero the field down a little bit to what we call in-memory data grids, or combined compute and data grids. So I've personally been working with these for 5 or 6 years. I've played with quite a few different, and I think fundamentally the concept of these technologies is proven. So that's a done deal. And what I think is holding back a little bit in this space is it's still a new model. So yesterday we had Romain from Finastri said, there's a mindset shift here. So developers need to get comfortable with this new way of working. But I think also in the industry, what might add a little bit of comfort in this space is a little bit more industry consolidation around, a few main players. Obviously, we still want competition here, but when there's many different players and not all of them are fully mature, you have this sort of niggling feeling, not only as a system designer, but also, when you're defending a particular technology choice to stakeholders, that what happens if this time next year, that another better alternative emerges, and that this year we're betting on the wrong horse. And so I think, given that it's now a proven technology, it's now time to stabilize and have a bit more steady state in the industry. That's a slightly long answer.
Yeah, no, I was going to say a similar thing. I think, as I talked about, sort of the idea of the fourth plinth, the core technologies are here. Obviously, they will continue to evolve, but the core technologies are here. So the real key thing is, as I said, organizations developing the applications to take advantage of them, and part of that, as you say, goes into just thinking differently, thinking beyond, the traditional approach of where you've got your OLTP systems, your OLAP systems, and we move data in between. It's just, there is an opportunity here, and again, I saw that in some of the presentations yesterday. Some organizations, they've developed, adopted Hadoop and the data lake rather than sort of data warehousing, or in addition to data warehousing, but it's still that mentality of the separation of operational and analytic. And yeah, it will take a change of thinking to drive the development of new applications that actually enable you to take advantage of that combined capability.
I think Matt just stole my thunder. That was what I was going to say. But I'll say it a different way. They say for a hammer, every problem is a nail. I'm a software architect, so every problem is architecture for me. And I would say that in-memory data grids and in-memory computing systems are not proven yet. We needed some controversy, so there's some. We can have some. Okay, so the problem is that I run into is that with customers is they have a siloed way of thinking. Oh, I'm going to drop in a grid as a cache, and then don't be messing with my application. And the problem really is you say, oh, look, you could move your application code into the grid and now do it much faster, not move data, better performance, and that's a head scratcher for most application architects. So what I think we need is proof points, a lot more proof points, and a good place to start is IoT. That's a driver because that needs fast, low latency computing to be effective. And so my feeling is once we have a few well-established proof points, the adoption will just accelerate tremendously. But we're really at this early adopter phase now where we are waiting for those proof points that we need to see in various verticals for wide adoption.
Okay, and the concept of digital transformation has come up quite a bit over the last couple talks and the last couple days. What role do you see in-memory computing playing in digital transformation, and if it applies to your company, what is your organization? Is your organization undergoing a digital transformation?
So I'm going to defer on this one because our organization is all about digital transformation and driving that in other companies. So let me defer to Matt.
Yeah, well, I'll pass. I think, obviously from the presentation I gave, yeah, we see it having a key role, potentially, at least, as I say, it's all about the execution, but yeah, I'll pass.
All right. Well, I suppose to answer the question very head on, yes, ING is one of the companies with a formal digital transformation strategy, and it is being worked towards in different ways. So I think David's already mentioned some of the things that they're doing on the retail side to meet changing, customer behavior patterns, and how to then map that onto existing, let's call them legacy or mainframe, systems that can't just be thrown away as quickly as customers start adopting mobile computing. And in FM, yeah, more data. I think I've already told this story earlier on, so I think I'll just pass on.
Yeah, I think it's probably quite hard to answer as well in terms of sort of different customers have different requirements in that space, but it's certainly, it's part of the toolkit that we offer in terms of digital transformation that we do on behalf of customers. It's not the only thing. I think a lot of it's also around the process and the people that are in place, and that sometimes needs to change as well as, the adopting these latest technologies, and we sometimes struggle to get the right skill sets as well to support these latest technologies.
I guess as a business, we're fairly recent and saw that it was an industry that was changing and really looking to kind of capitalize on that transformation and be B2B with it. So yeah, it's all about digital transformation in that way. But I can still see aspects even within being a normal business which are paper driven and other processes which could still be transformed. So even though our kind of B2B basis is about transforming industry, there's still aspects which are more traditional.
Okay. Tim mentioned machine learning. Do you see an intersection between in-memory computing and machine learning or artificial intelligence? And if so, how might it impact your organization or your industry?
I think always a lot of buzz about machine learning and AI. I mean, for me, there's in a previous life at a game account, we did a lot with more sort of AI on games, and we had sort of tailored AI for things like playing backgammon, and it worked really well for I know that neural nets work really well for backgammon, bearing off strategy, and they work less well for things like Go. Although I know that someone has recently done much better at Go than they did before. So I think it's at the moment there's a sort of buzz that machine learning is going to help solve a lot of different problems, and I think it's not. I think the reality is it's very difficult, even with just saying machine learning. It's like, well, what's the right algorithm there? Now there's going to be machine learning or AI for trying to pick the right algorithm to apply to machine learning. I've seen with Google, so it's complicated. I mean, I think it's got a lot further to go. I also think that the kind of noise in data, if there's a lot more data, then it doesn't necessarily mean that machine learning is going to be able to pick through that. I mean, maybe eventually it will, but I know if you just throw more noise, then it does make the whole thing a bit more confused. I guess my point is you still need to know what you're doing, and people, there's a lot of situations where people don't quite know what the answer is, and they're trying to solve it using machine learning, and yeah.
Yeah, we've not had a huge amount of exposure to AI or machine learning at this stage. I think, this technology is a concept that certainly helps underpin it. And I guess that will help it sort of evolve over time.
Yeah, thinking about the original question, will in-memory computing facilitate, applications of machine learning and artificial intelligence? For myself, I kind of see it difficult to separate the two. So when I think, in my own field and also from other experience, machine learning, like deep neural networks and so on, this is HPC, this is real HPC, and you need to be able to move a lot of data around quickly, and so traditional three-tier architectures aren't going to deliver you the type of performance or responsiveness that you need in a commercial setting. So I think this links a little bit to the non-volatile discussion we had earlier, or the presentation that was given earlier, I should say. So whether it's streaming in memory, I'm thinking, things like Flink, where you can model everything as a stream and pass it across a processor array. This is another type of in-memory computing, apart from data grids. But then I see data grids as facilitating that and giving the scale out that you need if, in a fast-moving, environment such as financial markets, it's difficult to separate them, I think, is my bottom line.
Yeah, I think if we look at machine learning and artificial intelligence, obviously one of the keys to that is having a very large amount of data. The more data you have, arguably, obviously the more accurate, sorry, the model. And so that, on the one hand, you can say, well, that doesn't necessarily lend itself to in-memory processing. But I think that you have to separate sort of the development and training of a model from the application of that model, or the delivery of that to an application, which increasingly, especially when we think about recommendations, as I've talked about from a retail perspective, that has to be delivered in real time as the consumer is engaging with the organization. So yes, absolutely, in-memory has a role to play. It's not the be-all and end-all, but definitely in terms of the delivery of that functionality through the the resulting application, absolutely, definitely.
Matt just did it again. Yeah, we probably should. So yeah, I think because in-memory computing systems are at the crossroads of fast-changing data, they're a very natural place to host machine learning systems. And just two quick examples that we've seen. One is e-commerce recommendations. If you think about it, you have vast amounts of shopping activity going on a large online site, and a machine learning system can find patterns and make effective recommendations. Another is predictive analytics for IoT. If you're looking at telemetry from machine tools or whatever, having a machine learning system to assist you in detecting a pattern that's going to predict a failure is very useful. I think Matt's comment that I was chewing on before he spoke was, that the training often has to take place offline, and it can take place offline, but the deep neural network can run, if properly architected, into an in-memory computing system. Final comment is, when you get down to actually doing it, the challenge is that the experts in machine learning really typically are not invested in understanding scalable in-memory computing. So it's our job as in-memory computing system architects to help create platforms in which they can easily drop their application code in. And in fact, the big challenge is getting the application code into the system such that the experts can worry about the application and the platform can worry about the orchestration.
Okay, and then final question. So the Internet of Things have come up a couple of times. What role do you see in-memory computing playing in the Internet of Things? And if applicable, what is your industry or your company doing around Internet of Things, and either now or moving forward here in the next few years?
Okay, I'll make a quick comment before Matt can speak. Yeah, I think I just touched on that. I do think IoT, we see evidence that it will be a driver of in-memory computing. It has some very natural characteristics that match in-memory computing systems. One is you have potentially thousands, hundreds of thousands of data sources from telemetry. You have the challenge of analyzing incoming telemetry by the data source, and that's where this digital twin model that Abe referred to yesterday, I think, is going to be pivotal in stateful stream processing because of the fact that it allows the application to zero in on the relevant telemetry and wade through all of the others to just focus on what is that data source telling us. And then this ability to then get higher and higher levels of intelligence about the whole population of data sources so that intelligent and rapid decisions can be made. So IoT and in-memory computing are fit together very nicely, and I think will really drive this industry.
Yeah, definitely. I think, because I started talking about retail in the presentation, I've sort of continued with that in my mind, but definitely IoT, we see a lot of examples around, particularly, as you say, in terms of sort of anomaly detection for predictive maintenance is definitely a real key application area. And I think, yeah, I mean, I'm fortunate, within the organization that I work in, obviously, as I said, my team looks after the core data platforms and analytics technologies. I borrowed some content here from my colleagues who follow specifically customer engagement. We've also got another team that's focused specifically on IoT, and obviously all those three areas potentially overlap. So we collaborate a lot around that. And so yes, yeah, it's definitely an important area for us, and because it's an important area for our clients. So yeah.
Yeah, I think there is some discussion in financial services and banking about Internet of Things, but quite what it means yet is I think, far from clear, certainly for myself. So ING is now beginning to invest in, so do some research projects around Internet of Things. And I think, the best I can come up with for now is the notion of the fridge that buys milk for you when it sees that you're running out. And so you might then infer from that this can lead to an ever-growing volume of transactions. So this will put ever more strain on, the legacy infrastructure that I've mentioned earlier. But beyond that, I'm not sure whether I should speculate right now.
I'm going to try and cop out as well. I think it's early it's early stages for us. I think it probably is something that we should be looking more at. The investors that we work with, I wouldn't say they're that active in. They're sort of looking for more sort of middle of the road established businesses that aren't exploring those types of technologies at the moment. That's likely to change obviously in the future, but it's obviously a developing space. I've just almost finished building a house which is fully automated, and we've just ordered a fridge that should be able to tell us if the milk's empty and all of that stuff. I'll find out in a couple of weeks whether that works or not, but we'll get to that.
Can that fridge also give you the odds on Argentina? Anyway, yeah. With sports betting directly, I can't think what the relationship is there. I think with sports data, gathering sports data in general, I think there's been big changes there, and that's the thing that has really revolutionised the industry, that there's more detailed data coming in, and things like wearable tech, players with information which is being gathered, and a lot of that is used by, I guess, kind of, coaching, as in terms of developing players in sports, but also directly into the data that goes into the sports betting industry.
Okay, well, thank you, everyone. Can I have a round of applause for our panel here?